Hi, this is Walter Stone, and this lesson is Unit 9, Lesson 2. It's about the quadratic formula. And after finishing this lesson, you should be able to solve quadratic equations by using the quadratic formula and use the discriminant to determine the nature of the roots of a quadratic equation. And the word roots is another way of saying solutions to a quadratic equation. So recall that a quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a is unequal to 0, because we do want this x squared term to be part of the equation. So one question is that gets asked a lot in an algebra course like this is, where does the quadratic formula come from? And one way of looking at getting the solution to this equation is using the process of completing the square. So in the prior lesson, we looked at the idea that we discussed that in order to solve by completing the square, we have to have a leading coefficient of 1. So one thing we can do is we can divide every term by a in order to get the leading coefficient to be 1. And then we can subtract c over a to bring the constant term to the right-hand side. And then in order to complete the square, we take half of the coefficient of x and we square it. So half of b over a is b over 2a, and we're going to square this number, and we're going to add that number to both sides. So on the left-hand side, completing the square means we can write the left-hand side as x plus b over 2a quantity squared. And on the right-hand side, this will be b squared over 4a squared. So what happens is when we simplify the left-hand side, if you have a common denominator of 4a squared, you'd have to multiply the first fraction here by 4a over 4a. So we would have minus 4ac over 4a squared, and then we'll have b squared over 4a squared. So what we usually do is we write the positive number first. So that's why we have b squared minus 4ac over 4a squared. So what we then do is use the square root property, and we take the square root of both sides. So we have x plus b over 2a on the left-hand side, and we'll have plus or minus the square root of b squared minus 4ac over the square root of 4a squared. And the square root of 4a squared is 2a. And then what we can do is we can subtract b over 2a from both sides, and we'll have minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, and then we have a common denominator, and we can write then the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, and this result gives us the quadratic formula. So if we're solving an equation of the form ax squared plus bx plus c equals 0, the solution will be x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, as long as a is not 0. We want this equation to be a quadratic equation. So in the examples we do, we're going to be using the quadratic formula to solve these equations. So suppose we want to solve x squared plus 7x equals 3x minus 1. The big deal here is that we have to have the equation in standard form. We have to have it in the form ax squared plus bx plus c equal to 0, and we don't have 0 on the right-hand side. So what we can do is we can subtract 3x from both sides. 7x minus 3x is 4x, and we can add 1 to both sides. So in standard form, this equation is, the original equation is equivalent to x squared plus 4x plus 1 equal to 0. So here, a is going to equal 1, b is going to equal 4, and c is going to equal 1. and we can substitute those values into the formula. So we'll have the opposite. What I like to do is I like to set up kind of a template that I can plug these values into. And I find it helpful because sometimes I have to make sure that I'm evaluating correctly in terms of the signs of the numbers. So I always put parentheses. I put parentheses for b squared, for a and for c, and for a in the denominator to fill in with these values. So we'll have the opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 1 over 2 times 1. And we'll have 16 minus 4 is 12. So we'll have minus 4 plus or minus the square root of 12. 12 is 4 times 3, so we'll have 2 times the square root of 3 will be the simplification of root 12. And both of these numerator terms are even, so we can divide both by 2, and we'll get negative 2 plus or minus root 3. So try solving the second equation using the quadratic formula and check your work. So here you can see I started u off, and here a is 4, b is negative 7, and c is 3. And I set up my template to fill in, and I made a little mistake, but b is negative 7. I made sure I substituted that correctly. A is 4, C is 3. So we have the opposite of B is the opposite of negative 7 plus negative 7 squared minus 4 times 3 all over 2 times 4. And here we have negative 4 times 3 is negative 48. So we have 49 minus 48 equal to 1. And the square root of 1 is 1. So we'll have 7 plus or minus 1 over 8. So this gives us two calculations we want to do. If I take 7 plus 1, I get 8 divided by 8, which gives me 1. And 7 minus 1 is 6. 6 over 8 is 3/4. So the solutions will be 1 or 3/4. So here, since we get these nice fraction and whole number solutions, it could be that we could have factored this on the left. And so it might be easier to make the choice sometimes to factor the left-hand side if possible, but using the quadratic formula will always work. Try this equation, solve by using the quadratic formula, 3x squared minus 33 equal to 0, and shut off the video and come back and check your work. So here, the 0, we have a 0 term here. The x term is missing. So we can think of this as 3x squared plus 0x minus 33. And 3 and 33 have a common factor of 3. So I even divided every term by 3 just to make things a little bit easier. And this is like, if we just take a little side trip here, this is like the equation x squared minus 11 that can be solved using the square root property. So we should get plus or minus root 11 as our solutions using the quadratic formula. So if we use the quadratic formula, a will be 1, b will be 0, and c will be negative 11. So if we take the opposite of b, we have the opposite of 0, plus or minus b squared will be 0 squared minus 4 times a equals 1 times c equals negative 11 all over 2. So underneath the radical we get positive 44. So we'll have plus or minus root 44 over 2, and 44 is 4 times 11. So this will be simplified to plus or minus 2 root 11 over 2. The 2's cancel, and we do get the two solutions of root 11 and negative root 11. So here we're just seeing that there are many ways to solve these equations now that we're building kind of a toolbox to do these, but the quadratic formula is something that will always work. The second objective of this lesson was to use the discriminant to determine the nature of solutions of a quadratic equation. The discriminant is that value b squared minus 4ac that is underneath the radical symbol. And we can use this to describe the solutions of a quadratic equation. So we're looking at the nature of solutions of a quadratic. So if b squared minus 4ac is a perfect square and a positive number, what will happen is we will get an integer. We'll have plus or minus an integer. And so what will happen is we'll get two different rational solutions for that equation. If the discriminant is a positive number that's not a perfect square, we'll have a number plus or minus the square root of a simplified radical. And so what will happen is underneath the radical we won't have a perfect square, and those numbers that are square roots of non-perfect squares are irrational. So that's why we'll get two different irrational solutions. If the discriminant is 0, then we'll just have the opposite of b over 2a, and that's a rational number. That's a fraction. And if the number underneath the radical symbol is negative, that's not a real number, so we'll have no real solutions. Later, you'll talk about we'll have experiences where we talk about complex numbers, and if the discriminant is negative, we get complex conjugate solutions. So you may have heard about that in the past. But right now we're just working with the idea that we won't have real solutions. So if I want to know the nature of solutions of this equation, we need to write the equation in standard form. So that's something to look out for, as we've done in some prior examples. So we can subtract 20x from both sides, and we'll have 4x squared minus 20x plus 25 equal to 0. So a will be 4, b will be negative 20, and c will be 25. And when we take b squared minus 4ac, we'll have the opposite of 20 squared minus 4 times 25. So we'll have 400 minus 400, which is 0. So because we get 0, we know that the equation will have one rational solution. And another thing that we see here, another interpretation of this will be a trinomial square if that happens. So it looks like this can factor into 2x minus 5 quantity squared. So that, and so we'll have 5 halves as a solution to this equation. And we can check that with the quadratic formula as well. Okay, so that's another interpretation, is if we have a perfect, if we have 0, we have a perfect square trinomial. So we can do a lot of analysis with these ideas. So try stating the nature of the solutions of each of the 3 equations in the try this exercise. Pause the video and then come back and check your work. So in the first equation, we had to make sure it's written in standard form. It turns out that b squared minus 4ac, that's going to be negative 3 squared minus 4 times 2 times 4. That's 9 minus 32, which is negative 23. So since that's a negative number, this equation will have no real solutions. In part B, the equation is in standard form, and a is 4, b is negative 5, and c is negative 2. b squared minus 4 times a times c turns out to be 56. 56 is not a perfect square, so we'll have 2 different irrational solutions. And in part C, a is 2, b is negative 9, c is 4. So we'll have negative 9 squared minus 4 times 2 times 4. And we'll have 81 minus 32, which is 49. And 49 is a perfect square, so we'll have 2 different rational solutions for that equation. Okay, so you can try solving each equation and check that this theory is correct. So the theory should actually, we could find the discriminant first and then try solving the equations. Okay, so Try the online exercises for this section, and we will see you in class. Take care.